Can. All right, so the first thing we need to do is find the equivalent resistance. So for equivalent resistance, you're adding all the resistors together in series and or parallel. Remember, you can't do them all at once, so you have to combine the gangs together. And now when I look at this, I can figure out immediately I'm going to combine these two in series. I'll do that in parallel with 2, and I'll combine all of that in series with 1. Now that may not be obvious to you. So if it's not obvious to you, here's how I would start it. I would draw as many loops as you can to start at the battery and end at the battery. So I start here at the battery, I go through 1, I go through 2, and I end up back at the battery. And then the other one I can do is go through 1 and then go through 3, 4 and then end up back at the battery. So those are my 2 loops. So I look at these 2 loops and I say, okay, of these 2 loops, what can I do immediately? Can I add 1 and 2 together? Well, no, because in loop 1 I go through 1, but I also go through 1 in loop 2. So I can't add R1 to R2 because it's like, well, do I add it to 2 or do I add it to 3, 4? Well, the answer is yes. So I can't do both. So I'm not going to do anything with R1 right now. R2 also, there's not really anything I can do right now. It looks like it's parallel with 3, 4, but I got to do something with 3, 4 first before I can do anything with 2. So now I look at 3 and 4 and I say, oh, 3 and 4, well, that's easy. We'll call this R3, 4. Those are series, so 2 plus 4 equals 6. And here's something that I think you might find helpful. Once you've drawn it and you've made your loops and you've found your first value, redraw the circuit. Now, you do not have to do this, okay? If you can look at this and you know exactly what the next step is, then just go to the next step. That's totally fine. You don't have to redraw the circuit. But I find it helps a lot of people. So I redraw the circuit now. I still have R1, okay, which is 4/5. I still have R2, which is 3. But then I don't have R3 and R4. I have R3, 4. So I'm replacing those 2 with 1. And the value for that 1, R3, 4, that value is 6. I just found it up here. So now I look at this, and again, I've got 2 loops. I've got this outer loop and this inner loop. Both of those loops go through R1, so I know R1 is going to be series, but I can't do anything with R1 yet, because do I add it to R2 or do I add it to R3, 4? Well, the answer again is yes, but I can't do both things. I can only do one thing, okay, at a time. So I can't do anything with R1 yet. But if I look at this, I see, hey, R2 and R3, 4, these are parallel. This is what parallel looks like. Parallel looks like this. It looks like things, 2 or 3 or 4 things all kind of connected together. Okay? So these 2 are parallel with each other. So I'm going to add those in parallel. So I'm going to call that 1 over R2, 3, 4. And if you're wondering why I'm doing 1 over, it's because that's how you do parallel. Parallel is 1 over what you're looking for equals 1 over R1 plus 1 over R2 plus whatever else there is. So in this case, it's going to be 1 over 3 plus 1 over 6. So common denominators here. Common denominator is 6. So I would multiply the bottom by 2 to get 6. I would also have to multiply the top as well, so it's a common. So 2 over 6 plus 1 over 6. That's 3 over 6. However, that's equal to 1 over r. I don't want 1 over r. I want just r. So I flip the top and the bottom. And that gives me r 2, 3, 4 equals 6 over 3, which you can simplify down to 2. Okay. Again, once I've done that, it's a good idea to redraw the circuit. So here is my battery connected to R1. R1 is still 4/5. Now I'm looking at this. I wonder why I picked 4/5. And then it's connected to 2, 3, 4. Okay? So 2, 3, 4 has a value of 2. Hey, let's make life easier. R1 is 1. Let's just make this easier. I'm sure at some point I had a number where like R23 was like 10/5 or not 10/5, like 9/5 or 3/5 or something like that. So I made it so it was already in that denomination. But I don't know why it was, because it's not anymore. And now I look at this and I'm like, okay, this is pretty clear to me now that this is series here at the end. Right, because here I am, I go through all of these to get back to the battery. So this would be series, so this would be REQ, this is for the whole thing, equals 1 plus 2 gives me an equivalent resistance of 3. So that's A. The answer to A is 3 ohms. So what work do you need to show? You need to show me how I got R34, how I got R234, how I got the total value. That's what I need to see. I do not have to see the redrawn diagrams. I do think it's helpful to do that, but you don't have to do that as showing your work. That is not a requirement. But I do think it's helpful in solving these. All right, A is done. Now we're ready for B. B wants to know the equivalent current. This is very, very, very simple. You are doing this equation, V equals IR. That's it. So V is the voltage for the whole thing. The voltage for the whole thing is 4. I is the current for the whole thing. That's what we're looking for. R is the resistance for the whole thing. That's what you got in A. So divide 3 to both sides. You get I equals 4/3. That's all B is. That's all it is. Every time. That's what B is going to be. Okay? Huh? Yeah, I would. Yeah, I'd include them. All right. Yes? If it's not clear what it is. Like if I can't tell easily for sure that it's resistance, then yeah. But like if you did something like this, where you wrote like 3 4/3, like if I can follow the work, oh, okay, here's I, here's R. If I can follow it clearly, no. But if it just looks like magic numbers, then yeah. All right. C, Find the voltage and the current for R1. Okay, this is where you have to do a little bit of creativity. Not a lot, it's a little bit. This is where you're using Kirchhoff's laws. So there are two laws that we've talked about for Kirchhoff's laws, and they are the the voltage around a loop is 0, and that the total current in is equal to the total current out. So that would be like into a loop or out of a loop. Okay. So I need to find it for R1. So I guess they're not written on here, so I'll write it on here. 0 equals the voltage for the battery plus the voltage for V1 plus voltage for V2 plus whatever they are. Remember, the V1, the V2, when you're doing those voltages, they'll be negative. They'll be negative. Yeah? Huh? BAT. Yeah, VBAT. And then the other one is current in equals current out. Okay. So I'm looking at R1, and I see R1 here, and I know the resistance for R1 is 1. Okay, that's all great and dandy. But I need the voltage and the current, and I don't know either. So there's a couple ways to do this. First of all, I will tell you right now, the one I give you for C will always be the easiest one. Always the easiest one. And they're either going to be directly parallel with the battery, or they'll be directly series with the battery. Always and forever. Okay? So I'm looking at this one, and R1 is directly series with the battery. Okay? It's in this first loop. It's in this first loop around here. So I look at that first, and I say, okay, R1 is what I'm looking for here. So in this first loop around, when I look at this first loop around, if I'm doing the voltage law, okay, so this first loop here, the voltage law would look like this. 0 equals the voltage for the battery, which is 4, minus, I'm going to go ahead and write them to you as minus on the test. I'm going to write them as minus. I'm going to write them as minus. That way you don't have to, I don't want that to be the mistake you make, is forgetting to turn them into negative voltages. I don't want that to be the mistake. Yeah?
So for the test, is it going to be like number 17 where the bonus is finding it?
Yep. Yep. Yep.
The others are like not required.
Be exactly like this. So all you'll have to do is A through C. D will be the bonus. Yep. All right. So then we do 4 minus the voltage for 1, which we don't know, minus the voltage for 2, which we don't know. Okay, so I can't do anything with that. So now I look at this and I say, okay, what about the current? So the current in equals the current out. And what we're talking about is like a node. Okay? So what we're talking about is the current going into a split, like here, equals the current going out through that split. So it would be something like the I through 1 equals the I through 2 plus the I through 3, 4. Okay? So I'm like, well, I don't care about that because R1's before it. So I look at R1 and I'm like, oh, I know exactly what the current through 1 is. Anyone know what it is just by looking at it? Because I know what it is just by looking at it. Cam?
1.3.
Yeah. Why? How do you know it's 4/3?
Because it in, out, same.
See how it doesn't split from the battery? See how it goes straight from the battery into R1? It straight into it. Well, that means it's got the same current the whole circuit does. Like, it's got the same current the battery has. So this is the current the battery kicks out. That full current goes through R1. So the current through R1 is 4/3. Just straight up. I didn't do any math. I was just like, oh, snap. That's what it is. Okay. So now I do V1. Well, V equals IR. I is 4/3. Now, the R is not 3. That's the R for the whole thing. I want the R for R1, which is 1. So the voltage is 4/3 volts. So there we go. The current for 1 is 4/3 amps. The voltage for 1 is 4/3 volts. So I just write that up here. 4/3 amps, 4/3 volts. And there we go. I'm done with the like that's all that is required for the test. That's all that's required for the test. That part there. I'm going to show you how to do the bonus, though. I'm not going to leave that. So, like, I want you to try the bonus, so I'm going to show you how to do it. Okay. For C, you can figure out the answer for C really without doing either of Kirchhoff's laws. Okay? Like, I looked at C and I was like, oh, yeah, the R1 is connected right to the battery, so it's got to have the same current. The other thing, if I didn't have R1 and I asked you for R2, I would look at R2 and I would be like, oh, R2 is parallel to the battery, right? Because I either go through R2 or I go through 3, 4. If it's parallel, it has the same voltage. If it's parallel, it has the same voltage. So C will be one of those two. It'll either have the same current as the battery or have the same voltage as the battery. Always. Like, I told you I'm going to make C the easiest one to find those two things for. And that's the easiest way to find them. Either it's the same current or the same voltage. So now I'm looking for these other ones. And these other ones are where you need to use these laws. Okay. So I said that for the loop law, I had 4 minus V1 minus V2 is equal to 0. So the battery minus the other voltages. And that's because they share the voltages with each other. Well, this is easy. 0 equals 4 minus V1 I just found, it's 4/3. Minus V2. Yay! So V2 is going to be, oh man, let's see how mental math is doing these days. 8/3. Okay, V equals IR. So
Wait, what voltage is V2?
8/3. Because,
What is it for?
huh?
Which one is it?
D. Find V and I for the others.
Oh, so is this for the second resistance?
Yep, this is for R2. Yep. So V equals IR. Oh, sorry, R. And that has a value of 3. Divide 3 to both sides. When you do that, you get I2 equals 8/9. The numbers aren't super nice, but they're not horrendous. Not terrible. Not great, but they're not terrible. By the way, I will give you bonus points for each part you get right. So, like, if the only one you can get is R2, I'll give you bonus for R2. I mean, not the full bonus, obviously, but I'll give you bonus for R2. So if you're like, I can do that one, but I don't know what to do with these, that's right. I'll give you a bonus for whatever you can do. I got no issue with that.
How would you do it for
Well, I'm going to show you, so be patient. All right. All right. I'm looking at this, and I'm saying to myself, hey, R2 and R34 are in parallel. See down here? See how they're directly in parallel with each other? That tells me that they have to have the same voltage. So the combined voltage for 3,4 has to be 8/3. But that doesn't tell me what the individual voltages are. So that's not helpful. However, what is helpful is I look at this and I'm like, oh, see how the current splits? And the current goes through R2, or the current goes through 3,4. So I can write this as the current in, so the current from 1, equals the current through 2 plus the current through 3,4. The current through 1 I already found. It's 4/3. The current through 2 I just found. It's 8/9. So that would be 4/9. It should be 4/9, right? So minus 8/9 to both sides. Yes, you can do them in decimals if you want. You can do them in decimals if you want. But I'm looking at that, and the current through 3,4 should be, it should be 4/9. And you're like, hey, Mr. B, that's great, but I don't want the current through 3,4. I want the current through 3 and 4. Well, my little exasperated friends, they're in series, which means they have the same current. So the current through 3 is 4/9, and the current through 4 is 4/9.
So for series, current is the same.
Yep. Parallel, the voltage is the same. Yep. For parallel, the voltage is the same.
And you can find what you had.
Yep.
On the other.
Now we do V equals IR. Yep. Now we do V equals IR. So the voltage for 3 would be 4/9 times the value for 3, which the value for 3 is 2. So that would be 8/9 for its voltage. And I do the same thing here. That's 16/9. That one's kind of gross. I swear these numbers were nicer at some point in time. And there you go. I'm all done. Again, I want to stress, D is the bonus. So if you're looking at this and you're like, Mr. B, I've got no clue on this bonus. I've got great news. You don't have to do it. So don't. Like, if that's what's confusing you is D, then just don't do D. Like, I would much rather you not even bother figuring out how to do that and just know how to do A, B, and C, because that's what's going to be graded on the test. Obviously, I would love for you to be able to do the bonus, but I don't want you to be like, oh, I don't know how to do any of this, when really the only thing you're having trouble with is D. All right.